Swift C++. This presentation is a little bit special for me because it's the first presentation I have that actually started with a title and no slides. And this very short before this event, because this event was a little bit unplanned. But Matthew asked me to have it for a rehearsal for his talk, and I guessed his title, and got all my guesses wrong. They said, breaking Enigma with the power of modern C++. And this is a way, Swift C++, comma, breaking Enigma with the power of modern C++. It's a whole sentence, it's also a meetup title, so Swift C++ is the title for my talk. And yeah, this is why I give this talk now. And I mean this Swift, the programming language, Swift. And there is also a reason why I had this even in mind, and it has a little bit to do with, let's say, carbon pollution during my vacation. So I was in vacation, like most people here in Sweden, in July, and usually I don't need to turn off my phone or make focus mode or something like this because I'm not on social media, but this time I got so bling, 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 did you hear new programming language, C++ interoperability, Google and whatnot. I said, okay, I'm on vacation. Then I came back from the first vacation trip, downloaded the stuff, based okay. I look after the vacation again. And after the vacation, when I wanted to look at it again, my brain was, wait, there was this other announcement about C++ interoperability. What's the state of this? So I looked into the Swift C++ interoperability, and then this talk came, and this is why I stand here now, so sorry. Yeah. But what is Swift actually? And for knowing what Swift is, we look a little bit into the history and the early 80s. And what happened in the early 80s? So this is not a JetBrains license refer, which I said will happen now. So what happened? What was important for us in the early 80s? So C++ was invented. Okay, Anna, you have won the JetBrains license. Can I have a second? That is not David Hasselhoff or something like this. Any idea?
Something to do with small talk?
Okay, let's count this. We will see why. So it was C++ and Objective-C. So both have their roots in the early 80s, or C++ maybe in the late 70s. And C++ we don't need to talk about it, we know it, it's our stuff. But Objective-C came from Brett Cox and Tom Love, who invented it and created the company, Stepstone. And they both have something in common. They both started as a preprocessor for C and added features, because both Björn Strostrup and the Objective-C people, they thought that it's awesome to have the power of C, the performance, and the control of the hardware, but they wanted to have the features of other language. And in the case of C++, it was the influence of Simula, and in the case of Objective-C, it was the influence from Smalltalk. And C++ had this way to C with classes, just a preprocessor, and then it became a compiler. And for Objective-C, it was C with Smalltalk, it was the object-oriented pre-compiler that compiled it to C, and then finally it became our own language with our frontend. And there is one more difference between, I mean, there are multiple differences, but one more important difference between Objective-C and C++. Can anyone guess what it is?
Only works in Mac.
I'll let this count.
Garbage collection.
It's Apple, of course. So without Apple, Objective-C wouldn't be that famous, maybe. So 1986, next, so there was the story from Steve Jobs, who founded Apple. When his plans rolled out, he created this company with Next. And he was looking for a programming language, and he found Objective-C from Stepstone that has been created, and licensed Objective-C. And 1988, several people from Stepstone dropped to Next and made a front-end for GCC. And then there was some issue with Steinman and the GNU, and they found a consensus, they could have it. And then 1994, Stepstone basically disappeared as a company, and all rights went to Next. And then Next was bought by Apple, and Steve Jobs came back to Apple. And this is the roots of Objective-C. And 2005, Apple started to participate in the Clang development. With Xcode 3.2, 2009 was the first time it was shipped to developer, wide scale. And since 2011, Clang is the default compiler for Apple developer, who produced Objective-C code very successfully, because if you think about the amount of devices, iPhones people use, and you think a lot of the stuff is Objective-C, it's an unbelievably successful language. Yes, in 2014, they announced Swift as a successor, so basically Objective-C without the C part. But the objective part is not the interesting stuff, everything else. So Swift is a modern programming language, relatively new, created by people at Apple. There's a lot of people that have their roots in the C++ community, so there is a lot of influence from this side. It has an awesome ecosystem, because if you're on a Mac and you use Xcode, it's your daily driver basically, and it's not a bad daily driver, but you need to learn something, right? Then you have a nice IDE. But it has also playgrounds for children to learn programming, where you move graphical stuff around and they can run it on the iPad, whatnot. It has a package tool, so the package ecosystem, which is Cocoa. With Objective-C, you had various Ruby implementation for package manager, and they were a little bit added, but now Swift has the specification for it and brings it from house. The documentation is, you go to swift.org and you find tutorials, a book, all the informations, like you have it with nowadays languages, but we miss in C++ a little bit. Terraform it works and so on, so it's very modern. And it shares a lot of things with Objective-C. So they are both built on LLVM. They have the automatic reference counting memory management. The garbage collector is not a garbage collector, it's reference counting. They share the same runtime, so this is one difference between Objective-C and C++. The Objective-C runtime is much bigger. It allows more dynamic things you can do at runtime, like against C++, which has not as smaller and more static. And they share the same language features. So there is some things are new in Swift, but a lot of things they have their roots already in Objective-C. And it's interesting to see what things these actually are. And to show you a small example why people became excited about this new language, and I've taken this from the first presentation of Swift. So on top you see the Objective-C code, and the syntax is a little bit. So this looks like C, everyone understands it, but this is a little bit already strange, right? This is the small talk part where you have some object, you ask if it has a method implemented, so you have this dynamic stuff where you can query object and send message, it's message based. If it has the object, if it has the method implemented, we call the message, it's a scroll view, and the delegate does its stuff, whatever it is, maybe taking how much did it scroll and refresh the screen or whatever. And in Swift, this all collapsed to one line, where you have these optional types. And if you access the optional, this has no value, there is simply nothing happens. So it will not throw an exception or something like this, which is very convenient. And as you see, the Objective-C part, were both, like we know it from C++, little awkward. Actually, pretty nice if you get used to it, but for new people to learn, it's not what people learn these days anymore. And the language was never designed to be beautiful. The language was designed to, in the 80s, what token can I take that my preprocessor or my compiler processes the source code and translated it, so it was not created back then to be beautiful. And let's have a short look at Swift in general. The variables, you have type inference, and you have variables and constants with var and let, and no surprise with this. As said, optionals, they don't crash if they have no value. They are created with the question mark. You can, of course, query, which is convenient. Did the optional have something or not? make it a little bit more visible, like in everyday code. You can, hey, if my variable from the optional get something, I do it. Or you have the opposite case, what you're mostly like a guarding stuff. If the optional has nothing, I do nothing. I return or whatever, so the code. And this created variable here, it is in the scope after this one. So the optionals are nice. Just a short, what are functions in Swift? So this is a function. I've taken the example we had at our last meetup is a very close, a server or client. So please note the variable name, and when we call the function, we pass in the variable name, which is Objective-C did this also already, which is, you need to get used to it, but it is nice. The funny thing is you can overload on this. So I can close a server, or I can use a client, and I call it like this. And this creates a unique design of how interfaces look like. So if you look a little bit closer, here I have a greet function. For the first parameter, I say I don't want that my user needs to pass in the variable name. But for the second parameter, which is down, I create an alias. And then we have this string interpolations, and here is the user side and greet Matthew. And here we have the from, which is the alias Paris. You are from Paris. So, and this makes, as I said, nice interfaces design. So Swift looks a little bit verbose. People like it to name the thing. 80 column limits is not a thing in this language. You get more this, but it's okay. One interesting thing, extend existing classes. And this is where we say we have this dynamic Objective-C runtime already, where we extend at runtime something. Monkey patching in other languages, where I can say, okay, a string is nice, but I want to have it an upper and a lower function. That gives me upper and lower. And I just define it for the class string. And when I do this with my name and call this function, I get this back. And this is convenient to make third-party classes match an interface that they don't have yet. You can do this also for int. I have this example here for two reasons. One, of course, lambdas, closures, you name it. Everything is there in Swift, but int is object type. So int is not part of the language, it's in the standard library. And when we define the times function for the integer type, and we take some function, we can call it, and pass in something that takes no arguments and returns nothing. I go no very fast over this because the details are not just to see a little bit. So Swift memory management is simple. If we have something that's a class, it's reference counted. So if we create something this is cyclic, you have a weak reference or something like this, like in other languages. And structs have value semantic. And in Swift this is taken very serious. Most things are structs and values. So every type is passed by value. And I said that our primitive types, that they are part of the standard library. Swift has also generics. No surprise for us. This is a swap function, takes any type. We can have an in-out parameter that changes the parameter, like a reference. You could also have, of course, multiple return values as a tuple. Just open a bracket and close a bracket and give them names like on default. But you see generics, and there are, of course, also generic types. So you can create your generic stack with an array of whatever. Mutating, very explicit about this change state. Explicit market. Push an element, we pop something if there is something. If not, we have this optional element. So we have the full generic programming. Properties are also interesting when you see this. I've taken two examples. This one is the first of all expensive property. Let's say this is a property when you initialize this class, it does something, network or database, whatever. And then you have a class that uses it, and you call something lazy. Then it will not be initialized when this class is created. It will be initialized on first use. And we can do this in C++ also, but we need to write it our own, right? Here we have a nice keyword for it, and if we create this class, and I have the value, this is not executed. Just when I access the value, then the constructor of the expensive object is executed. So this is the lazy keyword. And then computed properties, like we have our property, and we have a get and a set that does functions, and the set just takes a value and does whatever it does. So this is nice with properties. I thought also enums was to mention, because they are kind of nice. So here for this example I have a great error enum, and error is not a class, it is a protocol. We'll come to this. And I create two enum entries for it. And the one is too long on a ladder, and they can take arguments, these enums. So they can carry data, which is interesting. And when we use this and we're error handling, there is no surprise in this, right? I go through a string and I have no letter. I can throw this and can add the data. So I have basically data holder on the fly. And when we catch the stuff, we can stripe out the data and do something with it, which is also very nice thing. It's just this way of error handling. You don't see that often, because error handling often looks like this. So we have the question mark. We try to fetch data. In this case, let's check if data is in the cache. If it's there, we return it. If not, we continue. We fetch it from the server. If there is some connection issue with the server that throws the exception, we continue and return nothing, and let the user decide what to do with the nothing. So this is also a very nice way of handling try. And then there is, of course, this, I don't care about exceptions. If this doesn't work, please quit the program and restart the machine. Yeah. So protocols, I mentioned them, and yeah, sorry, the teaser time is over. But I want to, if you take anything of this talk from the Swift programming language, watch this talk from Dave Abrahams. Dave Abrahams is a very known person in the C++ community. Actually, he worked 10 years at Apple. He's now by Adobe again in the C++ department. He's in Parent. And he has a talk about protocol-oriented programming. And you totally understand it as a C++ developer, there will be no surprise, but it will change your point of view of programming if you can share some of the values that are shown there. And it's, given that it was 2015, and we have 2020, it's still very interesting. So when you come home, watch this talk. Yeah, so Swift, as said, I don't want to make a full intro into Swift, I just wanted to show you a little bit. Built on LLVM has the same runtime and mechanism for memory management as Objective-C does, plus some additional stuff. And there is, of course, a reason, right? There is a language interoperability between Swift and Objective-C from the very beginning, because Apple brings a new programming language and they can't say, well, let's throw away all the stuff we have, right? I mean, the whole ecosystem was built on Objective-C. Every GUI application was built. And at the beginning, you used this Objective-C stuff. Today, you use Swift UI, which is a very interesting topic for its own. But this interoperability was given from the beginning, and it was easy to implement, but easy to implement because LLVM, one compiler, share a lot of stuff, right? And of course, every programming language talks with C these days. That's how it is. And through C, you always have a little bit of a possibility to export C++, right? To make your interface C, but the implementation C++. And then you have no constructors and destructors. You need create methods and destroy methods and make this very C-ish, but some projects do. And it works fine for some projects. But it's cumbersome to write, and there are code generators that do this for you. There is also very interesting other route for Objective-C. And this one is Objective-C to Objective-C++ to C++. So Objective-C++ has been added somewhere on the road. And how it works is basically Objective-C has header and implementation like C++ stuff. So the header stays basically Objective-C. So the interface is there, you cannot change it, Objective-C. But the implementation file, this is if it's an Objective-C++ file, which is basically for the compiler just MM instead of M, you can mix C++ and Objective-C code in this translation unit. And the compiler knows how to link this and make it work. And there are several rules, like how to transform a std string to NS string or something like this. So some mapping needs to be taken care. But this works very nicely, and in this you can get C++ into Objective-C. And this has been used a lot. If you're an iPhone user, have some video conferencing software, so they for sure the multimedia processing happens in C++ using this kind of bridge to expose them to the user interface. And so this bridge you have, of course, the way from Swift, Objective-C, Objective-C++, C++. Now this sounds a little bit awkward, and in some way it is, but it works actually astonishing good. And there are many projects that do it. And at this place I would like to mention Genie. So Genie, we had a presentation pre-pandemic from Jonas. He was talking a little bit about C++ on the mobile space. Genie was created by Dropbox, then they stopped it. No surprise if creating such a tool is part of your project, because it requires a lot of resources, a lot of project time goes in creation of the tool. But when they stopped it, the tool existed, the project were using it, and there were several forks, and I created also one. And it is on Genie XLCpp.dev. Let's go there. It says nice documentation, how this works. So you can integrate C++ code into Java and Kotlin, Objective-C and Swift. Python is a little bit mostly done, but not 100% user-friendly, and C#, from which I don't know, this is done by people that work more on Windows like I. And how this works is actually, there is a generator, and you have an interface definition language. Is this huge enough for you to read? No? Let's zoom this a little bit. Okay? So, better? Yeah, good. So basically you have an interface definition language. You define types, which is either a num or a bit, a num type with bit flag semantic, records, which are structs, or interfaces, which are classes that are transported to the other languages via the shared pointer to the Java garbage collector, and so can handle this. And that's basically it. So you have a very simple user interface definition language, and this generates the code. It generates the C++ code, and it generates Java code, and you have the mapping of the types defined, how they map. And it does this also for Objective-C, how this mapping happens, and there are also some std types there, and for C# and Python. And that's basically, yeah. You can try it out if you want. If you want to participate in this project, please feel free to do so. The compiler is written in Scala. So if you are multi-language interested, this is your chance. I'm not very active in this due to time limitation, but it was a very interesting experience going to take this open source project, having users, having all these users with different interests, and oh, I cannot manage this. So it was really, really interesting for me. But the thing is still there, and let me show you some examples, but not just because of Genie, but for other stuff. So basically this project is a CMake project, and you set up your stuff, and we need a little bit of Java, and we process the interface definition language that generates the code. This requires a little bit of CMake magic behind the scenes. And then you get all this code generated, you add it to your library, and you're good to go. And then there is a little bit boilerplate, if you have never seen this before, for macOS, where you don't create just dynamic libraries. You can do, but what you create in macOS is so-called frameworks. This is another thing. If you're interested in this topic, let me know. And I will do this in an extra presentation. And then you use this. And the interesting stuff is so let me just show maybe the implementation is super simple. So you have this code. Oh, first you need to see the interface file. So for this example, it's totally unexciting. The interface file is just data, which is a struct, and then a class interface to C++, which has the interface implementation. We can get it by the ID or add a data or remove data and get how many elements do we have, and someone needs to create the whole thing in Objective-C or Java where you use it. So this is not very exciting. What is interesting is, of course, if you haven't seen this, CMake-wise, so I can totally create Java stuff with CMake, and I just say, hey, I use Java, and then you create Java jar, and set some properties and make it work. I don't go into the details, I just want to show that this is possible. And then we can even add tests that execute Java in CMake, which is funny. And the same for Objective-C, where you tell to CMake, okay, I enable the language Objective-C, and we need some upper magic, foundation, and so on. And then for testing, we have the Xtest stuff. I show this to remember this, that we use CMake to go to Objective-C. And CMake is also able to do Swift, where we do tell CMake, hey, this is a Swift project. And CMake kind of understands it. So CMake is used by the Swift developer themselves to compile the compiler, which is written in C++, by the way. And then we have this, hey, here is executable, it has Swift code. We link against the library, which we have created, and we need to include here a special directory. I come to this, and then we add a test. And this nicely works. And the interesting thing is this special directory, where we need an extra header file. And this header file includes Objective-C stuff, and yeah, here also Objective-C stuff that Genie generated for us. And we use this as a bridge header, so you collect usually all your headers from the libraries you want to export to Swift into this file. And it's called module map. And I've just seen this in Clang, and in Clang has a module definition language, and the documentation is it's subject to change and so on. And I think they have added it to Swift, because Swift is basically a zero configuration language. You tell the compiler where to find stuff or where to include stuff. Swift compiler goes here, finds this module map, looks in the module map, finds these headers, and then it knows how to handle these headers, how to name mangling and so on. And for the linker gets the required information. So for Swift, you need this module map because Swift external source code is organized into modules. So that's the start there. And the usage of the stuff is pretty simple. We have the storage, we create, then we have data, we create it with variable names, and then we add stuff. And yeah, that's not the exciting thing. But the interesting thing is the module map. Okay, that's Genie and the short example. So Swift and C++ interoperability, there will be or is a more direct approach, as mentioned. It is pretty new. It has been announced at the beginning of this year in the Swift forums, and it comes from Apple. So it's not a fan project from people that want to make it happen. It is Apple developer invest resources in doing this happen. And this is interesting stuff, right? So there is this, hey, here is it, here is the source code, everything is open source, you can look at it and monitor the stuff, and if you're a compiler writer, you can find a lot of interesting things there. There is, of course, it's early stage. Right? Don't use it for other things than play around with it. But how does this work, right? So I showed already the module map. So you create this module map with C++ headers. You tell in the module map that this is a C++ code. and then the Swift compiler will figure out link name mangling and so on, and will be able to consume it. Current state of this, I have here an example on GitHub that has just some very unexcited C++ code. I just have here a class with a constructor.
Can I make it bigger?
Oh, sorry, yes, of course. So, good. Yeah. Just to show that this is a real C++ code and not a C code, a struct, which has a constructor and a very unexciting move function. And they have implementation, that doesn't absolutely matter. What matters is the module map that Swift expects us to find. We have here the requires C++, that Swift knows what to do with this thing. In Swift you can simply implement the stuff and call the functions on it. So and import the name as you named it in the module. The whole state of this is very early. Yeah? So the easiest way for us maybe to do this is using CMake. If you're Xcode developer, you can use Xcode for this already and set properties. For me, Xcode, if you spend your every day in it, it's nice. If you just drop in, it's a little bit, learning curve is a little bit. And you can use the Swift package manager also to create C++ packages that interact with Swift. But I think for us, it's maybe CMake the easiest language. So we have here a project that uses C++ and Swift. We set it up totally normal. And then we have our library. I will say everyone that links against our library gets the include directory where the module map is. Then we have the Swift example that has the executable, and it gets this compiler flag. That it enables the experimental C++ interoperability. And then Swift just does the stuff. What it doesn't, it kind of works. I said the whole thing is in very early state. So if I go to, for example, GitHub Actions, and I run this project, so you can reproduce this actually. I print out the GitHub Xcode version to see what Xcode version is on GitHub Actions because it's not the latest one. We create a Ninja project, I make the debug and run the test, and we run the example. That gives a little bit different results on GitHub Actions than on the local computer, just because it's one Xcode version, so not major version, top version behind, right? So every new Xcode version gets new features that will be released as they are ready. But I can totally run it, I can make it work. The only thing is I currently have a problem that with XC-test, if it's an XC-test, but you can run normal binaries, and if you think about it, a normal app is just, as a test is just a normal app that returns 0 unsuccess or error code interface. So you can use this as a test. So this totally works. Yeah, the project is available on GitHub if you want to look at it. So and what can we expect? And to mirror this, the best place maybe is to look at the Swift repository. And there is a little bit of documentation for C++ interoperability. Not everything is super actual, but it gives you a good starting point. And if you want to monitor the current state, it's very interesting to look at the test and the interop folder. And there you have the interop to the various languages. And you have C++, so you have C++ to Swift, but you will also be able to store Swift structs in a step vector in future. And look what's going on here. And you see this is very active, so 22 hours, the last commit. And there is a lot of things going on. So they do a lot of things. And I said, constant development. So I think they take this very serious. And maybe in 2 years there will be something where you can go direct from Swift to C++. And we will see where this leads, because as we have seen at the beginning, when I talked about the history, Apple is able to follow long time plans. Very successful. I mean, there's a reason why they are so big as they are. They do some things they do pretty good, and on the technical aspect they do it interesting. It's of course driven by them. So we will see how far they do it. If maybe they stop it sometimes, say everything what we need works. But on the other hand, this is a total open source project, and it's not hard to contribute, and you can totally do this. And that's the current state. If you really want to have the latest feature, you need to compile Swift yourself, which is a little bit of a challenge. Okay, and this is my talk. I'm done. Thanks for listening. I think we can take, if there are 1 or 2 questions, we have 2 minutes to the break time. If there are questions, otherwise I would suggest you ask in the break and we go directly to the meeting. Yes?
I have a quick question. Before this talk, I have never read a single line of Swift before, so thanks for the talk. And I couldn't help but notice that some of those features are also considered highlights of the Rust language. And one of the selling points of Rust is the performance. So I wanted to ask, how does Swift, Objective-C and Objective-C++ compare to C++ in terms of performance?
Yes, this is also the question is, how does Swift compare performance-wise to C++? And it's of course a little bit slower, but this is why you get the interop. Right? If you most parts for a mobile phone, the performance doesn't matter, but then you have this thing where you process the audio or you process the video, and you want to have this part in C++, and I think this is why this interop is a thing that Apple even develops it, right? So performance is very good. Most things it's awesome. So I think it will be nicer than Java or something like this. Maybe you can compare it with Go. But yeah, for the field where it's used, user interface languages, convenience apps, iPhone stuff, awesome. Good performance.
Thanks.
Now I have 2.
Thank you.
Okay. Yes.
Do we have any plans on doing anything outside of Mac?
Yes, of course. Are there plans doing anything else than Mac? Swift runs on Mac, of course. It runs on Linux. There are Ubuntu packages and there are experiment Fedora package, so there are some other packages. If you're a field engineer, so crazy like I like to think, you can build it yourself. And since some time it even runs on Windows. So yes, and there is also the server-side Swift interest group that says, well, Swift is not just interesting for making user interface, even if Swift UI is very interesting, but Apple developers that live in the Swift universe, a lot of them need a backend, and why should they write a different language? And the same like the JavaScript developer have Node.js on the server, which is horrible, then the Swift developer can have Swift on the server side. And it was a little bit more hyped when IBM was interested in this, and then they stopped their project, but it's still very active. And I know about, from podcast, people that have created successful business apps by using Swift also on the server. And they run the server on Linux, of course, doing their database stuff, communication stuff, whatever they do. And the front end is the iOS, Mac, and other platforms.
What's OOPC?
This was the name of the first, what is OOPC was the question, the name of the first compiler that Brett Cox created, and it was like C++ was called C with classes, the first front end or first language. It was called object-oriented pre-compiler. That was just basically a preprocessor on steroid that translated the input to C code and then compiled the C code. Cool. Okay, I think we have time if we have more questions. Last one, okay?
Okay. It's like script is very new to me. So I saw one of the slides, it has mentioned that reference counting is for classes.
Mm-hmm.
So is that for class or objects? How is it different from the shared and the shared pointer in C++, shared and
Not very much different, actually not at all. Because the shared pointer is reference counted.
yeah.
Yeah.
So the reference count is for the class
Everything that is a class, yeah.
or object?
instance of classes or object.
Okay. Okay. Okay.
So the question is that about the reference counting mechanism for classes, how it behaves for objects. So an instance of a class becomes an object, and if you pass this around, there will be no deep copy happen. You share the stuff, and some things are shared by nature, like not network sockets or standard in, standard out, right? So there, or graphical user interface, there is just one main window. You don't want to copy this as possible. But this is where you still have the classes, and the reference counted is there. One interesting thing is, maybe this to mention, Swift does, and this we have forbidden this in C++ in implementation, copy and write. So copy and write is a thing in Swift. So this comes to performance. It's sometimes a little bit, do I copy this or not? but yeah, but classes is
Yeah.
Okay, cool. So I would say we start now with the Mingle part for 1 hour, and then we will have our second talk. Thanks for listening.